Welcome back. This is the third and last lesson recording for week 6 of distance learning for IM1. So where we left off is we left by doing the problem here where we actually came up with no solutions as our solution. Because why? You cannot have a negative number as a solution answer to absolute value function ever. So now we're going to go through another problem, this time 5 minus 4, absolute value of negative 2x minus 8, closed absolute value is equal to 5. In class, during the class, I asked students to solve this, so please pause the video now and see if you can solve it yourself. Okay, I am going to go through the answers in a minute. Here we go. All right, so again, we need to isolate the absolute things around the absolute value function first. That will be 5 and negative 4, so that we can isolate the absolute value expression by itself to be equal to some number. So that means we need to get rid of 5 and negative 4. Which one do I get rid of first? Well, since 5 is adding to the absolute value function, while as negative 4 is being multiplied to it, we need to get rid of the 5 first. So we subtract 5 from both sides, which leaves us with negative 4 times negative 2x minus 8 is equal to 5 minus 5 is just 0. Okay, and then from here, I am going to divide both sides by negative 4. Why? Because negative 4 is not subtracting 4 from this expression. There is a multiply implied right there. And so divide both sides by negative 4, and that cancels out the negative 4's and leaves you with negative 2x minus 8 is equal to, what's 0 divided by anything? Any number, as long as it's not 0, is just going to be 0. So then you have to be asking yourself, okay, can you have a positive and negative 0? No, 0 is just a 0. It does not have a positive value or a negative value. So you actually just have one equation in this case. Negative 2x minus 8 is equal to 0. And then from here, I am going to add 8 to both sides. And then you get negative 2x is equal to positive 8. Divide both sides by negative 2. And you get x is equal to negative 4. That's my solution. And again, I should be checking to make sure this is a solution. 5 minus 4, absolute value of negative 2 times x is negative 4. Minus 8, absolute value is equal to 5. So then 5 minus 4 times absolute value of negative 2 times negative 8 is positive 8 minus 8 is equal to 5. And 5 minus 4, what's absolute value? 8 minus 8 is 0 is equal to 5. And what is absolute value of 0? That's just 0. So that becomes 0 is equal to 5, and 4 times 0 is just 0 is equal to 5. So 5 is equal to 5, and it checks out. Great. Okay, so then we will move on to another problem. Okay, this is the final problem, example 4. You have absolute value of 2x plus 5 minus 4 is equal to 3x. So let's have a look at this problem. What is different about this problem? Well, up to now, when we have the x only occurred inside the absolute value function. It's never occurred outside. So this is something new. So x is outside the absolute value symbol, okay? But it's still the same issues. We still need to isolate the absolute value. So still need to isolate absolute value expression to be equal to something, just the same as before. So what are we going to do? We are going to get rid of this negative 4 because that is around absolute value function here. So therefore, we are going to add 4 to both sides. And that leaves us with 2x plus 5 is equal to, okay, now 3x plus 4. Please do not tell me it is 7x. 3x plus 4, can you combine those two? Can we add them up? No, we cannot because they're not like terms. So we are left on the other side as 3x plus 4, not 7x or not just 7. Now at this point, you should be thinking, okay, we have isolated the absolute value expression on one side. But we have a variable on the other side, the x on the other side as well. Same thing. That means that what's inside could be positive or negative. That means this expression could be positive or negative. So we are going to write two equations just like that. So that means 2x plus 5 could be positive version of this expression 3x plus 4, or it could be the negative version of this expression 2x plus 5 is equal to negative version, which means we're going to take a negative of it, 3x plus 4. So you have two equations just like before. Then from here, I am going to subtract 5 from, I see the two variables on either side. So let's deal with the variables first. Let's subtract 2x from both sides. And then this goes away and you're left with 3x minus 2x is just x plus 4 on the right hand side and is equal to 5. And then from here, I am going to subtract 4 from both sides. And that leaves us with x is equal to positive 1. That's my one solution. Let's go to the other side. Okay, so 2x plus 5 on one side. I am going to distribute this negative to both. Okay, so that becomes negative 3x minus 4. Then from here I see variables on both sides, so I want to combine them. So I'm going to add 3x to both sides to cancel this out, which leaves us with 5x on the left hand side plus 5 is equal to negative 4. And from here I am going to subtract 5 from both sides, and that leaves us with 5x is equal to 4 minus 5 is 9. Then divide both sides by 5, and then you are left with x to be 9 over 5. That's my second solution. Okay, now here's the important part. We need to check our answers. Okay, so let's check our two solutions. Checking. Let's check x is equal to 1. So that means go back to the original equation. 2 times x is 1 plus 5 minus 4 is equal to 3. Instead of writing x, I'm going to write 1, just like we did. Okay, so then 2 times 1 is 2 plus 5 inside the absolute value function minus 4 is equal to 3 times 1 is just 3. Then from here, 2 plus 5 is 7, the absolute value of it, minus 4 is equal to 3. The absolute value of 7 is just 7 minus 4 is equal to 3, and 7 minus 4 indeed is 3. So this one checks out. So we know that x is equal to 1 is a solution. What about, let's check the other solution. X is equal to 9 over 5. Let's plug it back into our original equation. 2 times 9 over 5 plus 5 minus 4 is equal to 3x. Okay, instead of x, I should be writing 9 over 5 as well to see if that is true. Okay, so what's 2 times 9? That's 18 over 5. Since we are adding a fraction with a whole number, I want to have the denominator to be the same. That means, how can I change this 5 to be some number over 5? I multiply that by 5. 5 times 5 is 25. Because 25 over 5 is same as 5 exactly. And I am adding those. Minus 4 is equal to, okay, 3 times 9 is 27 over 5 now. Okay, now I should be dealing with my fractions. Since they have the same denominator, I can just add the top. 18 plus 25. Okay, I think I've made a mistake. Okay, I've made a mistake. I am sorry. Okay, so this should be negative 9, right? So negative 4 minus 5 should be negative 9. And this should be negative 9. And so the answer is negative 9. And negative 9 here and negative 9. Great, so it should be negative 27 over 5. And this should be negative 18 over 5. Great, I think I am on the right track now. All right, so then negative 18 plus 25, what is that? That's just positive 7 over 5. Absolute value function, because we still haven't dealt with it yet, minus 4. Okay, minus 4 is equal to negative 27 over 5. What's absolute value of 7 over 5? This is where we're getting rid of the absolute value function. That just comes to be 7 over 5 because it's just a positive version of it. Minus, okay, 4, we are subtracting from a fraction, so I want to be adding and subtracting fraction. We want to have the same denominator, common denominator. That means 4 is same as one number over 5. 4 times 5 is 20. So 20 over 5 is same as 4. So this is what I have on the left hand side, and the right hand side stays the same. 7 minus 20. 7 minus 20 is just negative 13 over 5. Is equal to negative 27 over 5. Now look at this expression. Negative 13 over 5 is equal to negative 27 over 5. Is this true? No, this is false. That means that this solution x is negative 9 over 2 is not a solution. Okay, not a solution. So that means that our only solution is just 1 and nothing else. And so I am going to state my solution as that. Okay, so sometimes this is the reason you need to be checking your solution to make sure it works. Sometimes you are going to find two answers. Once you plug it back in, sometimes you're going to find that both of them work. Sometimes you're going to find that only one of them works. Sometimes you're going to find that none of them work sometimes. So all those cases are possible, so you need to be checking. And that is it for today. Thank you for listening.